Hey guys, IE.RVT here. We're looking at Module 5, Homework B, Tab 1, Part 3, Series Capacitors-Voltages. So in a series combination of capacitors, the charge on each capacitor is the same, as denoted by Q sub T is equal to C sub T times V, where C sub T is the total capacitance and V is the voltage from the battery. So the voltage across each capacitor can be calculated using the formula V sub I is equal to Q sub T all divided by C sub 1. Since Q sub T is the same for all capacitors, we can express it using the total capacitance. So now we're going to have Q sub T is equal to V, looks like a U, V divided by 1 over C1 plus 1 over C2 plus 1 over C3. And now we can substitute this expression into the voltage equations. So let's go ahead and do that. So V1 is equal to Q sub T all over C1, which we get V all over 1 over C1 plus 1 over C2 plus 1 over C3. I'm trying to write small. Multiplied by 1 over C1. And then that's our V1. And then now we can do V2 is equal, that does not look like a very good 2. 2 is equal to QT all over C2, which is going to be equal to V divided by 1 over C1 plus 1 over C2 plus 1 over C3. And this is going to be multiplied by 1 over C2. And that's going to be that. And then V3. So we're going to have Q sub T divided by C3. And that's going to equal to capital V divided by 1 over C1 plus 1 over C2 plus 1 over C3 times by 1 over C3. And that'll be our answer right there. So those are the voltages across each of our capacitors right there. The voltage across each capacitor in series circuit is inversely proportional to its capacitance. Capacitors with lower capacitance will have higher voltages across them, since they store the same amount of charge but have a smaller ability to store that charge, lower capacitance. This is why the voltage distribution depends on the individual capacitances. The sum of the voltages across all capacitors equals the total voltage supplied by the battery, consistent with the conservation of energy in the circuit.